the entire table where we are storing the data in the form of rows and columns are referred as a relation, another name of a table. Each column is identified by a distinct header called attribute or field. Another name of field is attribute. It represents each column. This enforcing the data, the right data to be placed in a right field or in rows and column, that is data integrity. Dear students, welcome to Computer Science Revision classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, in this session, we are going to talk about the database concept, chapter number 13. The weightage of the chapter is 16 marks. Here, 6 MCQ, here 1 MCQ plus 5 fill in the blanks and 1 2 marks question, 1 3 marks question and 1 5 marks question. So total weightage of the chapter is 16 marks. Now in this session we are going to cover the important topics of the chapter database concepts. In this regard we are going to cover introduction to database, database terms, DBMS, database models, ER models, keys, data warehouse and data mining. Let us start with the definition of database. So, database is a collection of logically related data organized in a way that data can be easily accessed, managed and updated. So, what is the definition of database? It is a collection of logically related data, or we can say it is a collection of records, and it should be organized in such a way that so the user find it easy for accessing, manage and updating the data. So this is the definition of database. Now let us see what are the different applications of database, and here few of the important applications of database. One is banking. Now all of you know nowadays everything is computerized banking. So all the transactions of any account holder of any customer will be recorded in computer. That is a very good example for an application of a database. And similarly, water meter billing, or we can say our electricity bill, water bill, everything is in the form of database. So all the details of the customer or the holders will be stored in a database with particular format. So with the help of that, it is easy for anyone to access the data, and so the water meter billing reader, one who come for reading a water meter bill or KB meter bill, so he will get you the bill immediately. That is with the help of a database. That is a very good application of a database. Next one is rail, airline and bus ticket reservations. Now we know that it is a centrally maintained database. So anyone can book any railway ticket or bus ticket or air ticket from any corner of this globe. That is the advantages of one of the applications of database. Now credit card transaction, and any transaction made through credit card, it will be recorded in the form of a database. And telecommunication, this is with respect to your mobile or maybe your landline or telephone connectivity. So all the calls recorded, maybe the duration, call, incoming calls or outgoing calls, all the date, time and duration, everything is maintained in a database. That is very good application of a database. And in terms of finance, sales, in manufacturing unit, that is to store the different raw materials required for any manufacturing tools. So this is in the field of manufacturing or in the field of automobile. And human resource, this is HRD, human resource department. So there is going to maintain the details on each and every details of any employee of any company. So these are all different applications of a database. Next, see the difference between manual and computerized data processing. So earlier, before the era of computers, everything was maintained through that is manually, or everything it was manual data processing. Now in the era of computers, we are using computers. Now we have changed from manual to computerized database system. So here let us see the difference between these two. So manual data processing, as all of you know, the volume of data which can process is limited in desirable time, because it is everything is taken care of or carried out by human beings. So it is because human being has a limitations, so the processing time everything is limited. And with respect to computers, so here process can be very large. So here it can be processed voluminous data, and here it is the volume of data will be very less. Now in manual, it requires a large quantity of paper, because that was a storage device. I mean, everything you used to store the record or the data on a paper in the form of a ledger, books, accounts, so many things. So it is mainly the manual data processing requires large amount of paper. But nowadays, less amount of paper. Nowadays, you might have come across the word, it is a paperless office. So we are minimizing the use of papers with respect to computerized data processing or electronic data processing. Next one is speed and accuracy is job is limited, because it depends on the human being. So the speed is limited and even the accuracy is limited. But here the job executed by computer or a machine is faster and accurate. Next one, labor cost is high, and here labor cost is economical. So next one is storage medium is paper, as we have seen in the second point. All the data used to store on papers in the form of accounts, ledger, so many books. And with respect to computer, storage medium is secondary memory devices in the form of floppy, DVD, CD, and so on, or portable devices. So that is nowadays we are using secondary memory devices as a storage medium with respect to computers. And maintaining backup is difficult. So what is the meaning of backup? To keep the record for long time. As everything is on the paper, we know what would be the life of the paper. So anything written on the paper, it will not last long. So that is the reason the maintaining backup is difficult. But here, with respect to computerized, maintaining backup is easy. So we can store the data in secondary memory devices for long time. So these are all the differences between the manual as well as computerized data processing system. Now let us see the database terms. The terms generally we use with respect to database. Now look at this is a table. So this is we referred as a employee table, and there we have employee ID is a one column, name, age, and salary. These are all different columns, and here all these stored in the form of a row. So this is one, here one name, age, and salary. This is what you call as one record, second record, and third record. So these are different terms we are using with respect to database. Now first one is table. Table is the main storage medium of a database. Next one is age and salary are called attributes. Nothing but the columns, the heading for this column are called attributes. And here the entire row from here to here, it is called a tuple, or another name is called a record. So it is a record or a tuple. And here next one is entire table is called a relation. The entire table where we are storing the data in the form of rows and columns are referred as a relation, another name of a table. And again, if you look at the value of one particular column is called domain. So this is and here in this example, table is employee, this is employee table, and columns employee ID, name, age, and salary are called columns, are referred as attribute. So here these are all different terms we use with respect to database. Next we will see the what is database terms with respect to file. Now let us the next definition is called a file. So what is a file? File is the basic unit of storage in computer system. The file is the large collection of related data. So here all the data we are storing in the form of a file. So that is the definition of a file. So all the data, related data we are storing in a file. Now database. So what is a database? As we have seen the definition, it is a collection of logically related data organized in a way that it can be easily accessed, managed and updated. Next one is tables. In relational database, and this is called RDBMS. The table is, what is a table? It is a collection of data elements organized in terms of rows and column. So table is a collection of elements organized in the form of rows and columns. Table is the most simplest form of data storage, as I told you in the beginning. So table is also called as a relation. See, these are the definition of different terms. In the next slide, we will see what are records. As I told you in the previous example, the single entry in a table is called a record or a row. A row of data or any data stored in a single row, it is called as a record, one record. So a record in a table represents set of related data. Another name is called tuple. Next, look at tuple. Tuple is nothing but a record. What are fields? Next definition is called fields. Each column is identified by a distinct header called attribute or field. Another name of field is attribute. It represents each column. Next, domain. As we have seen in the previous example, it is a set of values for an attribute in that particular column. So the values or the data in one particular column is called one domain. Next one is an entity is an object of a real word such as table employee. So here table is an entity. So these are different terms. Next we will see the definition of database management system, or what we say a DBMS. So here there are two terms. One is database, that is different with respect to, next one is database management system. Now let's see the definition. DBMS is a software which helps the user to perform operations such as creating, storing, retrieving and modifying data from a database. So now we know what is a database. Database, it is a collection of records, logically related data in the form of a table. So what is a database management system? So this another term, it is nothing but a software or used to work with the database for different operations. So if I say operations, it can be creation, storing the data, retrieving the data and modifying the data in a database or in a table. So DBMS is a software. It is actually a tool. It is a tool used to perform any kind of operations on data in a database. Now, some example for DBMS software are MySQL, Oracle, MS Access and DB2. There are a few examples of database management system software. In the next slide, we will see what are all different features of database system, or nothing but the advantages of database system. Now, the first one, it is centralized data management system. So, in a database, is a general concept is that all the data are stored in one centrally located place or in a centrally located system. And here, explaining for this, we can imagine that a very good example for this is if you go for any shopping mall, any mall, all the data you take for example of a mall. In that, all the data are stored in one place in a database, and all the users use this database simultaneously. So that is a very good example of centrally maintained database management system or data management system. So you take the example of a supermarket. For entire supermarket, there will be only one database. That is the concept of one database, and same database is used by different users inside the supermarket. So with respect to that example, we can understand this concept better. So one is centralized database management system. As I told you, in entire one system for any organization, there will be a concept of only one database, and all the users who are connected to that particular system will be shared the same database. So there is no concept like one user, one database. Now, second one is controlled data redundancy. So what is the meaning of this? It eliminates duplication of record. So it is controlled data redundancy is nothing but elimination of duplicate records in a database. So in a database, all records must be unique in nature. There won't be any chance of duplication of entries. So that can be avoided with the help of a database or controlled data redundancy. Next one is enforcing data integrity. So it refers to validity of data and can be enforced automatically by the database management system. So we know that the table is made up of number of rows and number of columns. So here the value of the data to be entered in a particular column or particular field is nothing but data integrity. So it's going to accept a same type of data for only each and every column in a table. This enforcing the right data to be placed in a right field or in rows and column, that is data integrity. Next one is called data sharing. What is data sharing? The data stored in a database can be shared among multiple users or application programs. This is, if you look at the example of a supermarket, there are only one database system and number of users. You can example billing counters. You can say there are maybe around 10 billing counters. All billing counter employees or the users, they will access the same database and simultaneously. That is the meaning of data sharing. Next one is ease of application development. So easily application programmer develop the application programs according to the user's need. So it is easy for developing an appropriate program for the users. Next one is called data security. So DBMS ensure that only means of access to database is through an authorized channel only, meant with respect to with prior permission. So in the example of a supermarket, all the billing employees are users who use billing software. See, they have given rights only to use the respective software or particular database, and they have not been given any rights to modify the data in a database. So that is a sort of data security. So it is possible to have security at different levels. So with prior permission or with authorized channels, it is possible to access the data. So this is data security. Next one is multiple user interface. So what is a multiple user interface? So here it provides, DBM provide different types of interfaces such as SQL, query language stands for SQL, application program interfaces and graphic user interfaces. So here the meaning of multiple user interface means the same applications can be accessed with different interfaces. So for example, if a same application or database can be accessed by a mainframe computer or microcomputer or laptops or your mobile. See, there is a very good example for different interfaces for the same application. That is an advantage, that is the feature of database management system. Next one is backup and recovery. So database, it provides backup and recovery from hardware or system failures. As all of you know that database is a collection of records and all the data are very, very important as far as any organization is concerned. So the backup and recovery, suppose in the case of any failures of the hardware or software system within any organization, so DBMS provides a method of backup and recovery so that any sorts of damage with respect to hardware or software can be minimized. That is backup and recovery. Now, in the next slide, we will see database users. Who are all database users? First one is application programmers and system analysts. There are two persons here. So one is application programmer and system analyst. So what is the responsibility of system analyst? System analyst determine the requirement of end users, and application programmer develops the software according to the user requirement. So here system analyst, first he determines the requirement of a user, and application programmer, he develops a software according to the requirement of a customer. Next, end user, another user, end users means the people who access the use or use the database for different application for generating reports. They are called end users. Next, database administrator, DBA. So it is responsible for coordinating and monitoring the use of database. As all of you know that database, it is all data are very important, and it also provides sort of security. So here DBA is the right person, or he's the one he's coordinating with the database as well as different users of the database, and providing easy coordination and monitoring the database and its users. That is DBA, or database administrator. Next one is database designers. So designers are responsible for or to identify the data to be stored in a database. So as per the requirement of a customer, the database designer, he is going to design the database so that different types of values or what type of values can be stored in particular database. In the next slide, we'll see different file organization. So there are different types of file organization or storing the data in different methods. Now we have learned in the previous slide what is a file. So now let us see what is file organization. Means how do you organize a file with respect to database. First one is serial file organization. So here with serial file organization, records are arranged one after another in particular order, either ascending or in descending order or with chronological order. See, this is nothing but serial file organization. So what is the meaning of this? If I say chronological order is nothing but with respect to the date. Now we might have come across in a computer, see all the files what you are going to store, it will be stored in one particular order to the date wise. So that is nothing but chronological order. So here files are stored in chronological order, that is serial file organization. Now it is commonly found in transaction data. Transaction data is nothing but, if you take an example of bank transaction, so all your transactions are stored chronologically or with respect to date wise. That is very good example for serial file organization. Next one is fast access to next record in a sequence, stored in economical storage media and easy to do the backup facility. Updating is slow in this file organization. So here all the records are stored in a sequence. So to access the next record, we have to access the previous record. That is a very good example of this. So here if there are 10 records, if we want to access the 9th record, so we have to access all 9th record. Next one we have to access the 10th record. So that is how the data or files are stored in sequential file organization. The records are stored one after another in ascending or descending order determined by the key field. So now normally how we are going to store with respect to student attendance register, we are going to write the name alphabetically or with the register number wise. That is a very good example for this. Next one is payroll system as well as in the form of employee ID. So you take any organization, all the data are identified with respect to a particular ID, that is nothing but employee ID. So here all the data, all files are stored with respect to in payroll system with respect to employee ID. That is a good example for serial file organization. Next, normally stored on storage medium such as magnetic tape, punched card, and magnetic disk. So here, with respect to computer system, a very good example is a magnetic tape. Magnetic tape is a storage medium where we can store the data with respect to computers. It is almost similar to our audio cassette, what we are using now. So audio cassette, in audio cassette, how the records are stored here one after another. If there are 50 records or 50 songs in particular one cassette, if you want to play 29th record, so first we have to forward all 28th record, then we have to play 29th record. So 29th song or a record, that is how the data are stored in serial file organization. If you want to access the next record, so from beginning till the previous record, it has to be accessed. Then only is possible for us to access the next record or next file. That is serial file organization. And to access this record, computer must read the file in sequence from the beginning. That's what I told you the point now. The first record is read and processed first, then record and file and so on. See, this is how it works with respect to sequential file organization. Next, we will see the random or direct access file organization. So here, the direct access file organization allow immediate direct access to the individual record on a file. So here, the record are stored and retrieved using a relative record number, which gives us the position of the record in a file. Say normally, how do we store the, for example, in any college or any school, we are going to store the student data with respect to a particular file, and we are going to arrange the file in different order with the file number 1, 2, 3, 4. So whichever the file we want to know, that whichever the record we want to access, directly we can go and pick up the particular file number for our different types of operation. That is a good example for this. And several types of storage devices including disk and other mass storage devices. If I talk about disk or hard disk, if you look at the hard disk in computer, we can store n number of files or different types of files. So here, whichever the file we are going to access, directly we can go to particular drive, either C drive, D drive, and directly we can access any record easily. But with respect to serial file organization, we have to access all the data in a sequence one after another, but in random or direct access, so directly a file can be accessed which are stored in disk or another mass storage media. This is direct access file organization. Next one is called self-addressing. So here under self-direct addressing, a record key is used as a relative address. Anyone can compute the record's address from the record key and physical address of the first record in a file. So this is self-addressing file organization. Next one is random access method. So here the desired records can be directly accessed using randomizing procedure or hashing without accessing all other records in a file. So it is possible to directly access any file without processing the previous record or without accessing serially or sequentially. Next one is indexed sequential access method, ISAM. So it is a hybrid between sequential and direct access file organization. And indexing permit access to selected records without searching the entire file. So this is ISAM. In the next slide, we will see the architecture of database management system. Database architecture can be seen as a single tier or multi-tier. So it is divided into following three types of architecture. One is logical one-tier or logical two-tier or client-server architecture. Next one is logical three-tier or client-server architecture. These are the three different types of database architecture. Now let us see the definition of one-tier architecture. Now here, the DBMS is only entity where user directly sits on the DBMS and user sit. So what is the meaning of this? There is only one layer. It is a one layer architecture or one tier architecture where we have only the database. Database will be in the one layer, and same database database is used by the users. And look at the example here. See, if you look at the diagram here, see, these are the computers. This is the file server. This is the only one server, that kind of file server, and accessed by 3 different users. So here the users directly work with the database system. So here any changes done here will directly be done on the DBMS itself. So because as the user directly works with the DBMS directly, any changes made, it has an effect on the original database. It doesn't provide handy tools for end users. So here directly the user works with that without any making use of any different tools. And preferably database designers and programmers use single tier architecture. So this is logical one tier architecture. Now in logical two-tier architecture, see, you can see the two tier here. One is called client tier, one database tier. And if you look at this here, these are the clients, and these are all different database server. This is the meaning of two-tier architecture. In this architecture, client is placed on a different tier and database is placed on different tier. That's the meaning of this. There are two different layer or tier. So here one is client is on one tier, database is on another tier. Two-tier client architecture is used for user interface program and application program that runs on the client side. This is where we are using two-tier architecture, and interface called ODBMS. This open database connectivity allows the client inside the program to communicate with the database. Here these two are on different tiers. So how do they communicate? Here this client is communicating with the database or with the server through ODBC or through a open database connectivity, that is nothing but interfaces. So this is how they communicate, clients and server architecture. In the next slide, this is logical three-tier architecture. So here, three-tier architecture, look at the diagram here. So database tier, presentation tier, and application. There are 3 tiers here. So here, the database architecture is commonly used architecture for web applications. So we are using this type of architecture in web applications. Intermediate layer called application layer or server or web server that acts like a medium for sending data between the database server and the client here. So here this is called 3 tiers or 3 layer. Here database is on one layer and application server or second layer, and web here in between we have an interface. So this is nothing but 3-tier architecture. In the next slide, look at the data here, another diagram here. This is 3 layers or 3-tier client, and here application, the application layer, application tier, and database server or database tier. Here database is here, and this is nothing but a client, and these two are communicating through application program. So this is an example for 3-tier architecture. Here data tier, application layer, and presentation layer or presentation tier. Next we talk about database models. So database model or simply data model is an abstract model that describes how the data is represented and used. What is the meaning of the database model here? It shows or it describes how the data are stored and how it can be used. Then these are the following are the 3 types of models, database model here. One is hierarchical model, network model, and relational model. Now let us see the definition of hierarchical model. Here it is the oldest type of data model developed by IBM. The data model organizes the data in a tree-like structure in which each child node can have only one parent node. So this is how a hierarchical model works. Here look at the diagram now. See, this is an example of a hierarchical model. This is a department number and department name. And if we have a course as well as student. So this is called hierarchy here. And here the course name, and here the student name, and here department. See, all these are going to form hierarchical model. Look at the example here. This is the professor is the ID. This is one data, and here root. This is how what we record what we have seen hierarchical model. It represents in tree structure. One is the root. Then we have the parent. Under that we have child node. Say for example, here we have the department is the root. Under that we have course, different courses under department, and we have different students for different courses. So this is an example for hierarchical data model. Next one is called network model. So in a network model, the data is represented by a collection of records, and relationship among data are represented by links. Here the database is nothing but collection of records. In network model, we are represented by record, and relationship among the data are represented by link. So here we are going to connect the data or different record through a link. Now look at the diagram here, this schematic diagram here. So this is a network model, and this is a department and student and professor and course. Here there are 4 different types of tables, or nothing but 4 different tables or relation. How we are going to connect here? So the department name as well as student name. So this student belongs to this department, here name, and this name is this course is for in the same department, and this student and this professor is going to handle the students of this particular course. See, that is how we are going to understand this here, and we are going to link the record through links. See, these are called a link, and this is nothing but network model. Next one is relational model. The relational model, it was developed by E.F. Codd in 1970. Here all data is maintained in the form of tables. In the form of tables known as relations consisting of rows and columns. The relationship between the two tables is implemented through a common attribute in the table and not by physical link or point. Now if you look at the previous example, here we are going to connect the different data through links, that is in network model. But in relational model, we are using, there is no physical link. We are going to connect with common attributes or common column name. Look at the example here. In this example, department is, this is one table, professor, course, as well as student. If you observe this, there are 4 different relations or 4 different tables, and all this, the values or the data are connected not through physical link, through a logical link. That is the meaning of relational model. Students, so far we have covered few topics of database management system. Now we will continue the remaining concepts in my next session. Thank you so much.